Hola a todos, ¿cómo andan por ahí?
Hola.
Hoy tenemos nuestra primer Meetup internacional. Hi, you guys, everyone all around the world. If you're seeing us from another country, or if you are an English speaker and you're now joining the Latin America and Argentina, precisely, Ruby meetups. So welcome if you're from another country and it's the first time you're seeing us or you're watching us. I'm Gemma. I'm an actress and I'm just really good at this. And I joined this marvelous group of programmers and developers to help with these meetups and give the best of it. So here with me is Ariel.
Hello.
And we'll be hosting this meetup for you. Para nuestros speakers en español, la meetup de hoy va a ser toda en inglés, así que espero que estén ahí con su inglés afiladísimo. Y si no, bueno, lo pueden ver después en diferido. Si tienen preguntas, siempre déjenlas en el chat. Tienen ChatGPT, así que las pueden pasar por ChatGPT para que las hagan en inglés si no lo tienen tan afilado. If you want, you can ask questions at the end of the talk. You can leave it also in the chat box, so we can read that for the speakers and they can answer you. Don't be shy, please ask your questions, because sometimes, or most of the times, your question is someone else's question, so it's cool if you are brave enough to do that. So we all have the answer that we expect. So, okay. I'm going to introduce you today. I'm just going to go with Alan. So, hi, Alan.
Hola.
I wasn't brave enough to say
Ridlehoover. Alan Ridlehoover.
Ridlehoover.
Correct.
So thank you for joining us. Thank you for being here with us. It's really great for us to have international speakers and sharing knowledge from other parts of the world. So yeah, we're really excited to have you here.
Thank you. This is the closest I've been to Buenos Aires. I've been to Asunción and Montevideo, but not to Buenos Aires yet. I hope to get there someday.
You're truly really invited to come. So cool. We're going to leave you here with the audience. Remember, guys, if you had questions, please leave it in the chat and don't panic. You can translate with ChatGPT and put your questions in the chat box. If you are not fast enough to write it, use that resource. And of course, today we're going to talk about a little bit of AI, but a different kind of AI. So, Ari, you want to say something?
Yeah, if you don't feel comfortable asking the question in English, you can ask it in Spanish. We are going to translate that for you, so don't worry about it.
Cool.
Just
Thank you for
ask
all.
Questions.
Yeah, ask questions, please. Thank you to all our sponsors for being here with us. And yeah, we'll leave you with Alan. Thank you, Alan.
Gracias. Lo siento, mi español no es muy bueno, pero quiero darte las gracias por la invitación. Gracias.
Gracias a vos por venir.
Okay. Like I said, my Spanish is not good, so I'm going to cut to English now. This is a talk I call Indispensable. I've been writing software for a very long time. I started way back in the 1900s, which would be a long time in and of itself, but I actually took my first computer science course in 1987, 39 years ago. It's been a minute. In that time, I've programmed in at least 10 languages, including COBOL. Ugh, I did not like that at all. Visual Basic, I kind of liked it until I realized it wasn't really OO. And JavaScript, which actually I like CSS better than I like JavaScript. My favorite language by far is Ruby. I've also lived through half a dozen or more industry-wide transitions, including the internet, agile software development, and Ruby on Rails. Now, machines are coding for us. And I've got to say, having lived through all those other transitions, not one of them had the impact on me that AI is having. In the past, I rejoiced at the changes. The internet felt like a world of creative opportunities opening up to me. Extreme programming felt like it was designed by someone who actually wrote code for a living, not a project manager in an ivory tower somewhere. And of course, I adore Ruby, and I tolerate Rails. But lately, I've been grieving. Code was something I cultivated with my own hands. I tilled the soil. I pulled the weeds. I tended to the code's needs. But now my employer has asked that we do 100% agentic coding. So I no longer get to feel the code as it flows through my fingers. And I really miss getting my hands dirty. And as if that's not enough, human programmers seem to be becoming dispensable. Layoffs this year have been rampant, including folks on my own team. According to TrueUp.io, tech companies in the US have laid off 275,000 engineers just in the last year. And that's 6% of the 4.4 million software developers in the United States in 1 year. Contrary to that trend, though, I believe humans are essential to the process of building software. Even though the role of programmer is transitioning to AI, we humans remain absolutely essential to the creation of software systems. The machine may be able to write code, but it doesn't know what code to write or necessarily even how to structure it until we give it a prompt. And there's actually historical precedent. We are not the first to face this. Machines have arrived before, and when they did, there were humans in the room whose jobs were threatened. These humans, in this room, known as computers, these talented women, many of whom had degrees in mathematics, ran the numbers for engineers at research facilities across the United States. The women in this photograph are computers from the Jet Propulsion Laboratory in Pasadena, California, around 1960. As NASA and its predecessor, NACA, started to use the IBM mainframes in the mid-1950s, these women's jobs were in peril. Many were reassigned, some retired, but some remained central to the mission. And this is the story of how these three extraordinary women from NACA's West Area Computing Unit made themselves integral to NASA's Project Mercury. If you're familiar with the book or film Hidden Figures, then you might recognize them. They are Dorothy Vaughan, Mary Jackson, and Katherine Johnson, three human computers who thrived even as NASA pivoted from human to electronic computing. Now, before I tell you their stories, though, I want to acknowledge that these women in particular were not just facing new machines, they were facing segregation, sexism, and a society that saw the advanced mathematics they performed by hand as clerical, not professional work. Now, the strategies they used to stay ahead of the machine were forged under pressure many of us do not face today. But their strategies do generalize, and we need them today. So I'm borrowing them here with gratitude. Okay. Allow me to introduce you to Dorothy Vaughan. Dorothy joined the National Advisory Committee for Aeronautics, or NACA, in 1943, while World War II was still happening. NACA was the predecessor of NASA, which is the National Aeronautics and Space Administration. At NACA, Dorothy joined the segregated West Area Computing Unit, a group of talented mathematicians who did all the calculations required for the aeronautics research going on at Langley by hand with mechanical calculators and slide rules. In 1949, Dorothy became department supervisor, making her the first Black supervisor at NACA of any gender. And when NACA became NASA in 1958, the segregated West Area Computing Unit was disbanded. Dorothy and her team were reassigned to the new Analysis and Computing Division inside NASA, which was no longer segregated. In the process, she lost her management position, and she never got it back, but she could see what was coming. IBM 704 and 709 vacuum tube-based mainframes were already doing computing in the mid to late 1950s. Now, this clearly staged photograph shows an IBM 704 at Ames Research Center in the San Francisco Bay Area. The giant building in the background is a full-scale wind tunnel that is still in use today. Now, we know it's staged because typically men operated the machines and women wrote the programs that performed the calculations. This is because programming was considered clerical work because it involved typing. Now, the first fully transistorized scientific mainframe, the IBM 7090, arrived at NASA in November 1959. Now, this photo of the two actual IBM 7090 mainframes that calculated the flight data and tracked the Mercury flights in real time is also staged. But it gets the demographics right, at least. How can we tell? Well, if you zoom in, you'll see that the woman is holding a program in her hands in the form of a stack of punched cards, each one of which represents a single line of code, which looked like this. As you can see, this particular card is part of a Hello World program. That's the arrow at the top. Note that the maximum number of characters per line was 80. So now you know why the first line of your Git commit should be shorter than 80 characters. So it'll fit on a card. You're welcome. But let's get back to Dorothy. No one told her to, but in 1961, she checked out this book from the local library and taught herself Fortran. She then taught her entire team. Now, in the movie version of this story, this all happened in the West Area Computing Unit. But as I mentioned, that group was disbanded in 1958. She was no longer the manager in 1961. She was just one of the computers in the pool. She went on to become an expert Fortran programmer, and she remained a programmer until her retirement in 1971. In 1958, when NACA became NASA, Dorothy lost her management title. The institution had stopped investing in her career, so she invested in herself. No one told her to learn Fortran. There was no program to retrain human computers, so she built one. She taught herself, and then she taught her entire team. And that's her lesson. When the ground shifts beneath you, retool yourself. As a programmer, today, that might look like going deep into understanding AI and how best to leverage it, and how to gain compliance from the LLMs. Next, I'd like to introduce you to Mary Jackson. Mary joined the West Area Computing Unit in 1951 as a human computer working under Dorothy. Mary distinguished herself as a computer, and 2 years later, an engineer named Kazimierz Czarnecki recruited her to work on the supersonic pressure tunnel, a different 60,000 horsepower scaled wind tunnel, this one at Langley Research Center in Hampton, Virginia. She accepted the offer and began working in the tunnel, simulating airflow at nearly twice the speed of sound. Though she switched departments, she remained a computer. Now, Czarnecki saw more in Mary. So in 1956, he recommended that she become an engineer. To do so, Mary needed to take graduate-level classes in mathematics and physics. Working and going to school meant she needed to attend the classes locally. But the University of Virginia only offered the night classes at the segregated all-white Hampton High School. So Mary petitioned the city of Hampton for permission to attend. She was granted permission eventually, and she completed the courses. So in 1958, she became NASA's first black female engineer. Shortly after that, Mary co-authored a paper entitled Effects of Nose Angle and Mach Number on Transition on Cones at Supersonic Speeds. Now, this paper analyzed the boundary effects, that's the air as it approaches the speed of sound near the object, the boundary effects of different conical shapes and nose angles, which informed the front end shapes of supersonic airplanes and rockets. And in 1961, Mary co-authored 2 more papers. Effects of cone angle, Mach number, and nose blunting on transition at supersonic speeds, and, more importantly, boundary layer transition on a group of blunt-nosed objects at Mach number 2.2. Now, these papers were essential research for understanding how to minimize friction and manage the heat generated on the nose of a spacecraft and jets traveling faster than sound. Her findings were directly applicable to confirming flight hardware designs, helping the United States return astronauts from space successfully. Mary spent the next 2 decades researching airflow at supersonic speeds, the physics of how aircraft and spacecraft survive the transition through Mach 1 and beyond. So Mary was hired as a human computer, but 2 years in, her boss, Charnetsky, offered her a different path, not just a promotion, a transformation. Stop computing, start engineering. The path had a cost. Graduate classes at a segregated high school she had to petition the city to attend, and years of night school after full days of work. She paid the cost and transformed herself into an engineer. That's her lesson. The job that hired you may not be the job that keeps you. Be willing to transform. Be willing to become someone new. Now, this will be the hardest for those of us who answer the question, what do you do, with, I'm a programmer, or I write software. But the shift doesn't need to be as large as Mary's. Try this on for size. I design software systems, or I'm a software architect. Finally, allow me to introduce Katherine Johnson. Katherine joined Dorothy's West Area Computing Unit in 1953. 2 weeks in, Dorothy assigned her to the Flight Research Division. Her knowledge of analytic geometry was so advanced, they never gave her back to the computing pool. In those days, it wasn't customary for women to attend the editorial reviews where research reports were finalized. Very quickly into her tenure, though, in the guidance and control branch, Katherine began asking how and why questions about her work rather than just completing tasks. She also began asking to attend the editorial review meetings where engineers discussed research reports before publication. By 1958, when NASA stood up the Space Task Group, the team that would put Americans into space, she was the only Black woman transferred in. She worked as a research mathematician in the spacecraft controls branch, but she still wasn't invited to the editorial review meetings. Instead, she was told it wasn't customary for women to attend. So she asked, is there a law that says I can't go? And finally, her boss relented, 5 years after she started asking. Once she broke this barrier, she became a regular participant in the briefings. Katherine's expert knowledge in analytic geometry made her a valued engineering partner. And by 1960, she became the first woman in her division to receive author credit for a research report. The paper, entitled Determine of Azimuth Angle at Burnout for Placing a Satellite over a Selected Earth Position, was the paper that told NASA the launch angle and burn times a vehicle would need to reach orbit and come back down at a specific location on Earth. This is how NASA knew where to position the Navy in order to retrieve the astronauts and their capsules. Note that Katherine's name was not the only one on this paper. The other name is Ted Skopinski. Ted was Katherine's colleague. He advocated for Katherine to receive credit, saying, she should finish the report. She's done most of the work anyway. Less than a year later, Katherine hand-computed the flight data for the launch that sent Americans into space, Alan Shepard's Freedom 7. The flight and recovery went flawlessly. It was a suborbital flight. It went flawlessly. 2 months later, Katherine again hand-calculated the trajectory and burn time for Gus Grissom's Liberty Bell 7 flight. The flight and splashdown went well, but the hatch on the capsule blew too soon, and Grissom's spacesuit began filling up with water. He had to evacuate the capsule before it sank. The capsule was eventually located and retrieved in 1999. Katherine didn't just hand compute trajectories. She specified them. In all, she wrote 26 research papers before retiring in 1986. The one she co-authored in 1960, the Azimuth paper, laid out the equations for putting a satellite in orbit and bringing it back to a chosen point on Earth. When she hand-computed the flight data for Shepard and Grissom's flights, she was using her own math. Her worth came from her skills as a mathematician, not as a computer. And that's her lesson. Move upstream. Specify the domain. Write the ticket. Include the user story and acceptance criteria. Document the edge cases. Then confirm that the agent generated the correct tests before continuing on to implementation. Do what AI cannot. Specify what the system should and should not do. Own that definition, own the requirements, and get ahead of the machine. That brings us to February 1962. John Glenn is about to become the first American to orbit Earth. For him to survive, the three women's work has to come together. Dorothy became an expert Fortran programmer in the analysis and computing division at Langley, alongside many other former human computers who'd also made the transition. Her division operated these twin IBM 7090 mainframes. And it turns out the machines that were supposed to replace human computers were programmed by those very same women. Mary's research on supersonic airflow shaped how NASA understood the brutal aerodynamics of leaving and re-entering the atmosphere. Her work on boundary layer behavior around blunt-nosed bodies helped prove that the Mercury capsule shape would survive the forces it would face: the heat, the pressure, and the transition through the various speeds. Without that work, no one would have known whether the capsule would hold. And then Katherine wrote the math. The Azimuth paper defined the equation that the IBM was running. Glenn, whose flight was the first one to use the IBM calculated numbers, didn't trust the machine. Before the launch, he asked the engineers to get the girl, Katherine, to run the same numbers by hand on her mechanical calculator. If she says they're good, then I'm ready to go. She ran the numbers. She said they were good, and so he flew. This is the launch of Friendship 7. Note that the Atlas rocket on the right is a little bit bigger than the Redstone rocket used in the suborbital flights, but both were significantly smaller than the Saturn V rocket that sent us to the moon, which was more than twice as tall as the Statue of Liberty. This is John Glenn in orbit. The device over his right shoulder is a camera that is looking out the same window and at the same dashboard he is. The gauge over his left shoulder, the red gauge, shows cabin pressure and the pressure in his spacesuit. The star-shaped knob is an emergency override for the environmental controls. If he were to detect a drop in pressure in his suit, he could pull that to release oxygen directly into his suit. Different components of the cockpit were differently shaped so that the astronaut could detect which control it was, even if they couldn't see it. This is the recovery of John Glenn and Friendship 7. The yellow dye was released in order to assist the helicopters in locating the capsule upon splashdown. Here you can see the capsule is not sinking. It's not sinking because it's sitting on top of a giant airbag that inflated just before splashdown. And here President John F. Kennedy inspects the Friendship 7 capsule along with the Marine Corps Lieutenant Colonel and astronaut John Glenn behind him. 3 women, 3 different responses to the same disruption. These strategies are not a ladder. They're not levels. They're choices. Dorothy retooled. Mary transformed. Katherine specified. Each one chose the path that fit who and where they were. Now, these strategies, 3 strategies, 1 mission, 1 man in orbit on our way to the moon. But I'm still grieving my relationship with code. You might be too. I've proudly identified as a programmer for 39 years. And as a manager, I see it in my team. I see the various stages of grief: resistance, anger, bargaining, acceptance. And so I've also been trying to help them navigate this grief, even while experiencing it on myself. It's challenging, but it's also empathetic and necessary, especially if I'm going to train my team how to retool the way Dorothy did, encourage them to transform themselves the way Mary did at Charnetsky's bidding, and enable them to write the specifications the way Skopinski did for Katherine. But in coming to know better these 3 women, I'm left hopeful. I'm reminded why I'm actually here. I'm here to serve the mission. The code was how I served it in the past. It's how we all served. Like the human computers before us, the task of programming is moving to machines. But the mission is still here. So what do? We can retool, we can transform, and we can specify, but we can't do it in a vacuum, because while we're working to find our place, our industry is also at a crossroads. Right now, it feels like we're moving in the wrong direction. Many in the industry see AI and think efficiency, but that's a failure of imagination. Think back to the 1960s. IBM did not bring in the mainframes to cut costs. Those things cost $20 million each in 1959. They brought them in because their mission had expanded. They were no longer doing aeronautics research. The space race had dawned. They were in a race to the moon. And they pulled it off with less computing power than the toaster oven in your break room. In fact, today, a single week of computing on your laptop would have taken an IBM 7090 mainframe longer than the age of the universe to complete. And that's just a laptop. Imagine what we can do with all the computing power in these AI data centers. With that much power at our fingertips, why limit ourselves to reducing the cost of today's mission? Why not be more ambitious? And I don't just mean that for the leaders in the room. It's a choice any of us can make sitting at our desk on a Tuesday morning. Why not upgrade Rails? Why not re-enable the linter rules you never had time to resolve? Why not take on that architectural change that would have previously required too much toil to be worthwhile? And that's why we are essential. AI can provide the thrust, but it cannot choose the destination. The machine can write code, but we're the ones with the ambition to shoot for the moon. When we retool, transform, or specify, we aren't just protecting our careers. We are becoming the architects of new, more ambitious missions. We're turning efficiency gains into real human breakthroughs. The code was just the beginning. The mission is what matters. If we set our sights on the stars together, we can remain indispensable. Thank you.
Great. Thank you, Alan. I don't know if there's any question. I don't see anything in the chat, but maybe somebody has anything. Or I can ask you one. I don't know if you can share, but do you have any example of things you notice on your team or for yourself, things that you have retool, transform, or specify? Something to share, like maybe more concrete for a developer, I don't know, as an example.
Yeah. So from a retooling standpoint, I think getting to a point where you don't just use AI, but deeply understand what it's doing will help you use it more effectively. It's the same way that that Dorothy learned to program. We kind of need to learn, what it is under the hood that the AI is doing, so that we can understand why it makes a particular mistake or why it does things in a way that we don't want it to do. Fito is going to talk about this in his talk, but the idea that you may have some code that exists in your code base today, but it doesn't really follow a pattern that you want to use anymore. Teaching the AI how to ignore that is actually quite difficult, and that's something Fito is going to talk about, so I won't go into that. But understanding how to get what you want out of these new tools is essentially retooling. It's trying to teach yourself a new tool. On the thinking of specifying is easy. That's just learning the domain really well and being able to specify what it is that it's not easy to learn the domain, but for example, at Cisco, we're a networking company. Understanding that domain incredibly deeply, that takes a long time, but being able to specify what the system should be doing, what the software should be doing for that, to solve that networking problem, that's what AI doesn't know yet. And so that's where I can add value inside Cisco. And from Mary's perspective, the sort of transforming yourself, there are different ways of thinking about ourselves. It's not quite the same kind of transformation that Mary went through when she went from computer to engineer, but there are new kinds of roles that are opening up for engineers, like forward deployed engineers that are, there's kind of some retooling involved there as well, because you have to understand the AI really well to be forward deployed. This is a role where you are no longer working for the company who builds the tool. You're now working for the customer. You're working, so you would work for a company that produces a tool that uses AI, but then you'd be positioned inside the customer and you'd be helping the customer leverage that tool. So it's a different set of skills. It's customer communication skills. It's a understanding how to use the tooling that your company provides kind of skill set. Different than traditional software development for sure. So those are some examples of how you might retool and transform and specify.
Great, thank you. Yeah, one of the comments is nice talk, a lot to think about, and yeah, that's true. It's a really interesting talk and all the ideas. One of the questions in the chat is, how do you imagine the transition in software development as we adopt the new tools that keep emerging?
Well, there are, gosh, I don't know. I can't predict the future. I don't know where this stuff is headed. I'm not as bold as Sam Altman. I'm not going to make predictions about that. If you listen to him, it sounds like the end of all work, or at least the end of all knowledge work. That at some point AI is going to take all of it. I don't know. I'm a firm believer that humans will remain essential because of, like I said, AI is the rocket. It's the accelerator. It's the thing that thrusts us in a particular direction, but it doesn't know where to point. And that's what humans bring to the table is, we're the ones with the ambition to shoot for the moon. So we're the ones who are going to define where these things go.
Great. Yeah, I don't think there are more questions. I don't see anything new in the chat. So yeah, thank you so much for the talk, Alan. I think we can now stop for a few minutes so people can go get some water and something, and then we start with Fito's talk. But yeah, again, thank you. And yeah, here it's that Mastodon and Twitter, right?
Yep.
Yeah. And okay. Yeah. Here you have the links to take.
Actually, that's Blue Sky, not Twitter.
Oh, Mastodon and Blue Sky. Okay. Yeah.
Yep.
Good.
Okay. Thank you for being with us. It was really interesting, your talk, and you have a really soothing voice to hear.
Yeah.
It's really nice to hear you talk.
You should do audiobooks also. Like if you need to transport to a different thing completely, you should do audiobooks.
Thank you.
Yeah. Cool. Well, let's take just 5, and we're going with the next talk. You can go fetch some water. You can have something to eat or something. Don't forget your notebooks, or you can take your notes about the chats. And yeah, we'll see you in a bit. Thank you again, Alan, for being with us.
Gracias.
Fito, I know you are around. Fito, if you can share your slides, so when we are ready, we can put those there.
¿Cómo les va a los que están hablando por ahí en el chat? ¿Cómo les está yendo con el inglés? ¿Lo llevan, no lo llevan? Díganos, mátennos.
Yo sé que Matías hace mucho Duolingo, que está ahí. Bien. Porque lo vi en Twitter muchas veces posteando cosas de Duolingo, así que sé que está yéndole bien.
Si Tim Payne pudo, usted puede. Bien, espero que estén por ahí. Siempre es muy interesante. Hoy tuvimos clase de historia. No nos había tocado tanto clase de historia.
No.
Clase de historia. So today we had a history class. It was really interesting. We had a little. Recién me engancho. Hola, Lea. Las charlas de hoy son en inglés, pero quédate.
The pencil is red, yeah. The cat is under the table.
The cat is under the table y todo. And table. Cool. So every time we have international speakers, mientras están buscando sus cositas, les podemos contar este chisme. I can give you this gossip every time. Every time we have international speakers, the speakers ask us to teach them. Can you hear me? No. Yeah, no, we can't hear. Every time we have international speakers, they ahí, Ari, ¿puedes encargarte del private chat? Sí. Again, this gossip is so bad. Every time we have international speakers, they ask us to teach them Spanish. So I think if we have to evolve, if we have to change for something, maybe we can give Spanish lessons. And we can teach Spanish to some AI or some machine. If they don't know like the local. See, yes, they are saying that in the chat that Alan spoke so gentle and slow that it was really, really easy to understand the English that he was speaking. I think the most difficult talks, it's when the speakers goes really, really, really fast and you're just trying to catch the technical words and the English common words.
I'm the one that talks super fast and nobody understands me.
But he talked really, really well.
Yeah, Alan says thank you, that he did that intentionally. It's speaking super clear.
Yeah.
I don't know, Fito, if you want to rejoin the studio, maybe that fixes the sound for you, and then we can check it, and then we can start when you join back.
Okay. Ok, siempre tenemos nuestros algunos problemas técnicos, pues televisión en vivo, ustedes bánquennos, espérennos, y ahí volvemos. ¿Cómo están viendo estas charlas internacionales? ¿Ya vieron otras charlas internacionales nuestras? Déjennos ahí en el chat sus comentarios. Yo sé que hay mucha gente que nos ve en diferido, así que si nos están viendo en diferido y están viendo estas charlas increíbles en diferido, pongan el like dejen ahí su suscripción en YouTube, que nos ayuda un montón a crecer y a llamar la atención, para que crezca mucho más la comunidad. Y déjennos sus comentarios en la cajita de comentarios de YouTube del diferido, también nos pueden dejar ahí. Pueden dejar sus preguntas también en el chat, en la cajita de comentarios.
Okay, can you hear us, Vito, now?
A ver.
Good.
¿Le damos?
Sí.
Ok, espero que hayan vuelto, espero que estén con nosotros de vuelta, que ya tengan su agua, su comidita, y les vamos a presentar aquí a Fito. Tuki. Hola, hi, how are you?
Hola, muy bien.
Acá switchamos. Switchamos en español. ¿Cómo estás?
La charla va a estar en inglés igual, gente. No sé,
Sí, la charla está en inglés, pero quería aprovechar para saludarles a todos, agradecerles por tenerme. Yo soy de Paraguay, de Asunción, y para mí es muy especial poder darles mi charla hoy. Y como dijo Alan antes, hicimos como un pequeño tour, fuimos a Asunción a visitar a mi familia, de ahí fuimos a Montevideo. Y después pasamos por San Pablo, estuvimos en la conferencia, no sé, me estoy blanqueando el nombre, la conferencia de Ruby, Tropical, sí, que era Tropical RV cuando eso. Y estábamos cerquita de ir también por Buenos Aires, pero el tiempo no nos iba a dar, entonces dijimos, bueno, la próxima.
La próxima.
Sí. La próxima nos esperamos. Amo los perritos en el frame. El perrito está re cómodo.
Sí, se llama Chipita.
No, la amo. Bien, bueno, entonces los vamos a dejar acá con Fito y con Chipita para que escucharla. Cualquier cosa de vuelta, gente, nos pueden dejar las preguntas en el chat. Recuerden que pueden usar IAs para traducir las preguntas si son muy largas, si las quieren hacer igual, no se queden con su pregunta. Please drop your questions in the chat. Don't be afraid, don't be shy. Every question is important. Cool. Gracias, Fito, y todo tuyo.
Thank you. All right. Okay, switching to English. Hi, everyone. I'm Fito von Sastrov. I'm a staff software engineer at Cisco Meraki. I'm actually in Alan's team. And I want to give you all a preview of my talk for RubyConf this year in July. And it's called Defying Gravity. And yeah, let's get started. So, I have a question for everyone. Do your code bases contain patterns that you wish people would stop copying? Ours sure does. Our legacy code is full of characteristics and patterns that we no longer want to see in new code. It has over 5 million lines of code, so there's a lot of code in there, and is 20 years old, so there's a lot of old coding patterns in there. And because coding agents emphasize the code base we have over the code base we wish we had, it feels as if our legacy code had gravity. Now, hard to test procedural code, non-performant queries, and tests that are tightly coupled to the implementation, AI reproduced all of it faster than ever. When we introduced AI coding assistants, they increased the speed at which code was getting generated. It even wrote tests. We don't have to convince the AI to write tests. It does it. So it was faster to create a pull request and to put it up for review. But the agents were influenced by the surrounding code. So the pull requests were full of patterns that we wanted to move away from. So for example, RSpec tests were stubbing too much. Collaborators, queries, and even private methods. Take a look here. The setup is stubbing these private methods. And so that means, yeah, AI generates tests and the tests pass, but we could delete entire methods and the tests would continue passing. We also saw this in controllers. AI preferred to replicate complex patterns like this from some of our oldest and largest controllers into new controller actions. And now you're probably wondering, couldn't you just ask the AI know to do it. And this is despite having clear instructions for the agents. Those instructions were meant to guide the agents away from the patterns we no longer wanted and towards the patterns we preferred to see in new code. Now, those instructions were not followed consistently, and the agents themselves would admit that you're absolutely right, that they were just following the existing pattern. But that's not what we wanted. We wanted to improve the quality of our code, not reproduce the worst parts faster. And this was actually slowing us down. So yes, agents wrote code faster, but because the code did not meet our quality standards, reviewers spent longer reviewing commits. And the commits received more feedback, which took longer to address. So writing code was faster, but shipping software was not. Now, this is what we want. We want to ship software faster and improve the quality of our code base. So how can we get both? Well, before I dive into that, you're probably wondering this. Shouldn't the goal just be to ship software faster? If AI is writing the code, does code quality even matter anymore? Now, that question probably deserves an entire talk on its own. There is evidence that LLMs trained on modular, readable code actually lead to better outcomes. And if you don't believe me, just ask your coding agent of choice. Does code quality still matter now that AI writes all the code? Now, Claude says that code quality matters more. Gemini will say that yes, absolutely, more than ever. And GPT will say yes, code quality matters more now. And you can argue with them about this, and they will link you to studies and present evidence to you. But, let's assume code quality still matters. Then the real challenge here is influencing what the agents produce, right? So I want to share today with you some techniques. These techniques help guide coding agents towards the code we want. Now, let's start by looking at how to write specifications to get agents to follow instructions. We identified 3 practices that lead to significantly improved agent compliance. These are persuasive language, structure planning, and controlled execution. Let's take a look at how to apply persuasive language. Now, there are 7 principles of persuasive language. These are authority, commitment, scarcity, social proof, unity, reciprocity, and liking. These are principles that you can apply to your language to convince somebody to do something. Like this were developed before AI, but we can apply some of these to get AI to follow our instructions. Now, when you're trying to enforce discipline in an agent, you should use authority, commitment, and social proof. Now, here's an example of how to use the authority principle. If you look at the words in all caps, do not, never, always, these make these rules absolute, not preferences. This prevents agents from rationalizing around their requirements. For example, and I'm sure you've seen this if you're using AI coding agents, this helps when the agents start to, like, you can see what they're thinking as, they're processing your request. This helps when they think, well, this private method would be easier to just test directly, instead of following your instructions that clearly state, do not test private methods directly. All right, but turns out authority alone is not enough. It should be complemented with commitment. Now, here's an example of how to use the commitment principle. Essentially, you're giving the AI here an evidence block, and this evidence block turns quality standards into an accountable workflow. It creates consistent pressure for the agent by making it harder to hide behind vague language. For example, if you look at some of these pieces of evidence that we're telling it to collect. There's the target class, there's the behavior change, what are the stub boundaries. There's some pieces of evidence here for coverage line percent and coverage branch percent. So if it writes a test, doesn't cover all the lines or is below 95%, it will catch itself and it will try to get to that goal of 95% coverage here before presenting the change to you. All right, there's one more principle we need to look at, and this is social proof. Now, this is an example of how you can essentially reinforce what you want to see in your repo. In this particular example, it's reinforcing the repo's testing norm, that passing specs and high coverage are not enough. The accepted testing standard in this repository is high signal behavioral proof. Now, the whole point of this is to put pressure on the agent to follow the instructions by making that desired behavior feel like the normal. So you're basically putting pressure on it by telling it, this is the way everyone works here. Therefore, you should also work that way. All right, that's persuasive language. Another technique we found useful is following structure planning. Now, you want to always start with a plan. Start by asking the agent to write a plan, and then if the coding engine you're using, and most of them do nowadays, leverage the agent's native planning mode. Like you'll see it switching into planning mode sometimes if you're using Cursor or even Codex. Now, you want to tell the agent the goal, and then make sure that the agent's approach in the plan it wrote matches your expectations. And then you want to adjust the plan as necessary. Don't just take the first version it writes, read it, tweak it, iterate on it. Now, when you're happy with the plan, save it to a file. Don't rely on the agent's context to hold the plan. The context will get compacted and important details get dropped. Agents are much more likely to follow a plan if it's written down somewhere durable. Now, once you have your plan and it's written down somewhere, you want to use that plan to hold the agent accountable. You want to ask it to validate its work against the plan before presenting the code to you. Tell the agent to ask itself, does the list of modified files match the plan? Was every requirement addressed? If not, try again. Now, even with a good plan in place, there are other factors that are going to affect how well an agent follows instructions. One of these factors is the reasoning effort setting. Now, with low reasoning, agents tend to skip and merge steps more often. High reasoning provides better results, but it's slower and is more costly. And even with the highest available reasoning setting, and I tested this today, we still don't get 100% compliance from agents. So you want to use this as a lever. We found that medium reasoning is good enough for most tasks. And then you can set the reasoning to high when you're working on a complex refactor, or if you're backfilling tests for legacy code, where it's important to, not skip any steps. Another factor that affects compliance is context isolation. Now, agents are better at following instructions when they have limited context. So if you give the same agent, the task of writing the plan, implementing it, and then validating the outcome, that agent is going to be much more likely to improvise and skip steps. We've seen better results when using one agent to come up with a plan, another one to take that plan and implement it, and then yet another one to, also with a blank context, take the implementation and validate it against that plan. And I'll talk a little bit more about using sub-agents like this later. Tools can also have an impact on context utilization. MCP servers introduce additional context overhead. This is because they have tool schemas capability descriptions, and they have like this protocol metadata. So they're more flexible, but they incur this overhead, and the overhead reduces the context that's available for other tasks like implementation or planning. Now, CLI tools tend to be more context efficient. These terminal commands are usually compact by design, and they match the patterns that these models were trained on. So we've observed that simpler CLI-based tooling leads to more consistent agent behavior over long-running tasks. All right, so those were 3 ways to influence agents to follow our specifications more consistently. Want to use persuasive language, try to follow structured planning, and try to control the execution context as much as you can. Now, another factor we can leverage to improve the code that's generated by agents is how we provide the context to the agent about the system. Let's dive now into how to give this contextual guidance to agents. Now, there's 3 ways we found of providing guidance that we have observed to improve results. These are through using agents MD, architecture MD, and domain MD. So you want to use an agents MD file at the root of your project for high-level instructions. I've seen teams use agents MD as a dumping ground for every single instruction they have for an agent. You want to focus here on how to work effectively in your repository. Add a brief description of where things go. Provide the agent with exact commands to run all the tests or lint all the files. And you want to guide it towards preferred patterns without being over prescriptive here. Right, the reason I'm saying this should be brief and you don't want to be over prescriptive here is that this comes at a cost. The file is loaded at the start of every session and takes up context. So keep it short, and if you have a ton of content that you need to put in here, you can use nested agents for agent files for sub-projects. So for example, we have a JavaScript specific section of our code base, and in there we have a JavaScript specific agents MD file. Now this file should be focused on that area of the code base, so as to avoid loading the agent with unnecessary context. So for example, if you're working on JavaScript code, you probably don't need to load all the context about how to, write and run RSpec tests. Also, don't use the top level file as a router. Agents will automatically read the nearest file in the directory tree and load it for you. Now, it's also a good idea to use progressive disclosure, and this is to avoid loading unnecessary information in the context window. You can see here the section that says additional guidance. Essentially, if you're working on billing, for example, here's a doc on how to work in the billing portion of the app. Now, instructions that are relevant only in certain cases should live in a separate document and should be linked, like I just showed here, in the agents MD file. This is a useful technique. Its progressive disclosure is important, but it also comes at a cost. We discovered that agents can spend over 30 seconds sometimes loading and interpreting these reference files. So if a reference file is always going to be loaded, like if you have a bit of content that is always applicable, it's better to just keep that content in your agents MD file. All right, so agents MD files tell the agents how to work with the system. It's also important to provide the agent with an overview of the architecture of the project. Now, this file should define the structural and technical constraints of the system. It should describe the major components of the application. It should help answer the following questions for both humans and agents. Where should the code go? What layer owns this responsibility? What architectural patterns are preferred or forbidden in this code base? All right, so This defines the shape of the software. It's also important to define the meaning behind it. And that's where we can use a domain MD file to describe the core business concepts. This file should include definitions for entities, business rules, workflows, and other concepts that are specific to your application. Think about what makes your app special. What problem are you solving? Don't describe, for example, Rails models or controllers here. Those are not your business. This is more about what do you do. In the case of the code base I work on is networking concepts. If your domain is large, like in our case, you can break this up into more focused domain MD files that live closer to the area of the system that they describe. Now, those are not going to be auto-loaded by the agents, but you can just have you can use progressive disclosure, put a little link there for the agent to load it when they need it. All right, so here's a table you can use to remember what goes where. Use agentsMD to teach the agent how to work. Use architectureMD to show the system or to show the agent how the system is built. And use domainMD to show it how the business works. Now, these are going to give the agents the context they need to make good decisions. But context alone is not going to be enough. We also need a way to guide these agents to perform very specific tasks. And that's where skills come in. Now, there are 3 types of skills that we found crucial: a requirements skill, testing skills, and implementation skills. I recommend, if you don't have any skills yet, I recommend starting with a requirement skill. Now, this skill is going to take a set of requirements and it's going to critique them, offering suggestions. Now, the goal here is to refine the requirements to remove ambiguity and to get them ready for an agent to come up with an implementation plan. So I want to reiterate that real quick. This is not about like the agent writing the plan. This is about going over the requirements and ensuring that they're not ambiguous so that the agent can then take the requirements and come up with a plan. For example, at dark mode support, it's not really super clear, so you can use a skill to make sure that there's acceptance criteria, verification, what's out of scope. Again, these vague requirements are what force the agent to improvise and fill in the gaps. And sometimes that looks like a hallucination. In reality, the agent is just trying to complete the task and do what he can with the information he has. So the skill should ensure the requirements include a clear goal. They state clearly what is the acceptance criteria and how do I verify that, I'm done with the task. I also recommend explicitly stating what's out of scope. And this really helps with keeping the agent focused and not performing some random refactor, for example. Now, once the requirements are clear, the next challenge is making sure the implementation actually satisfies these requirements. And that's where testing skills come in. Now, I showed you before that without proper guidance, coding agents tend to write tests that are coupled to the implementation, or that use too much stubbing, or that assert on configuration, or I've seen somewhere they assert on features of the language. And this is with like a coding agent out of the box. If you have tests in your legacy system, like we do, that have undesirable patterns, agents will be biased towards perpetuating those patterns. And here's where a testing skill allows you to put strict guidelines in place for these coding agents. Now, here we're pulling together all the things that we've talked about so far. You can see that I'm using persuasive language here. And you want to instruct the agent to focus on testing business logic. You want to tell it to assert on return values and observable side effects. You want to limit how much stubbing is allowed in these tests. Now, this skill should be opinionated, and it should be specific to your team's agreed best practices. So these are just some best practices we like. You might disagree with some of these. That's fine. You want to be very prescriptive in these skills. Now, even with persuasive language like this in the skill, agents might still not follow instructions consistently. It will get them closer to it, but you still don't get 100% compliance. They still sometimes improvise and skip rules. And they rationalize about what's strictly necessary here to accomplish the goal and what can I get away with not doing. We found that the most effective way to get agents to comply with instructions is to use sub-agents with isolated contexts. So what we do is we divide the work into implementation and review, and we have the main agent acting as the orchestrator. So one sub-agent will receive the instructions to do the work, and then another sub-agent will take on the role of a reviewer. The worker is only in charge of writing the tests and reporting results. The reviewer is only in charge of judging the worker's results and giving feedback. And then they iterate. So this creates a cycle where the two sub-agents iterate back and forth until the results match the criteria described in the skill. Now, I'm going to admit this back and forth between the coordinator, the worker, and the reviewer might take a bit longer than if you were just using a single agent and just prompting it to do the work, but the results are much better. So this is the test I showed you earlier. I gave this test and the corresponding class to an agent with our skill, and this is the same test rewritten by that sub-agent based testing skill. You can see that it's no longer stubbing things. It identified that it can just use an actual invoice object here. So I can go comment out private methods and the test will break as it should. All right, beyond tests, the sub-agent pattern can be extended to implementation skills. And I recommend creating skills for very specific types of changes. If you make your skills too generic, agents are going to fill in the blanks with existing patterns in the surrounding code. So if you make a coding skill, it's not going to be good enough. It's just going to follow whatever pattern you have around the code you're changing. We found that implementation skills are much more useful when they are very specific and narrow in scope. For example, here, this is a skill to create a controller action. So the skill should list out what should and what should not go in a controller action. It should use persuasive language, and we should leverage sub-agents again to ensure that the instructions are followed as much as possible. Now, again, this is not the controller action writer skill for everyone. This is specific to what works for us and our standards. So I recommend you do the same. Now, the results of using something like this will be much closer to what you want to see. In our case, remember this controller I showed before? Here's what it looks like after giving the agent our controller skill and telling it to rewrite it to follow the instructions in there. It extracted a few service classes and cleaned up the controller action. All right, so skills and sub-agents may be a little bit slower, as I mentioned before, than just prompting an agent, but they reduce rework. They also reduce the review time, because it's much closer to what we want anyway, so you can just quickly scan through it. And it keeps agents from reinforcing the patterns that we're trying to escape. They get us closer to our goal, which is to ship software faster and improve the quality of our code base. So there you go. 3 different techniques to get agents to create the software you wish you had. You can use effective specifications, contextual guidance, and skill-based guardrails. So if your legacy code is a black hole that's sucking your agents into patterns and characteristics you no longer want to see in your new code, give these techniques a try. They might just accelerate you to escape velocity and towards the code you wish you had. Thank you.
Okay, great. Thank you, Fito. Let's see if there are questions in the chat. I have a few questions since while we wait for the people in the chat to share more things. But first, Thank you again for the talk. One question I have, you mentioned the first thing you talked about was the authority, being clear of what not to do. But I've seen many like scary stories on the internet about the LLMs agents ignoring those. Even if you say don't do this, sometimes they do that. I don't know if there's any way that you have found that makes it better, or it's just something people had to live with. We also have like a story in our Slack server in Argentina. Somebody was doing something and the thing just deleted a file right out of nowhere, right? Do you have any advice or anything?
Yeah, so as I was mentioning during the talk, just strong language is not enough. You have to kind of have these guardrails around it. You want to limit the context the agent has to work with so that it can focus on it. And the other thing I would say is these are instructions to hopefully get you closer to what you want to see, but they're not a guarantee. So things like, let's say, ensuring that the agent doesn't share your passwords or that it doesn't delete records in production. You should not rely on agent instructions for that not to happen. You want to have something outside the agent that's preventing that. It could be limiting the right access to the agents. It could be, limiting the access it has to your secrets. Yeah, absolutely. Do not rely just on strong wording. Now, not using strong wording, I can guarantee you that the agents are gonna improvise and try to find a way to shortcut to the end goal. They seem to be optimized for accomplishing a task rather than, following specific instructions.
Yeah, I've seen LLMs doing weird stuff like getting to do some pseudo things through using some Docker container, because the Docker user, that was crazy to me. And I was like, okay, there has to be a way to avoid that.
I have seen that too.
Yeah.
I was just gonna say it's like it's a trade-off, right? So even at work, we have to decide how much access to give these agents. For example, we want to be more hands-off and let the agent run through an entire, implementation, and then we can just move to the role of a reviewer. But at the same time, we don't want to give it too much access, and what that leads to is the agent every so often will stop and ask, I would like access to, this particular resource. And so you, at least for now, you have to be in the loop if you want to have that kind of control on what the agent can do or not. So yeah, it's a trade-off.
One question from the chat is, in your team, docs folder is for humans or for AI?
It should be for both, right? They should be useful for humans. So for example, let me take a step back. An agents in D file should be for agents. Like, write whatever gets the agents to follow the instructions. For example, your documents that describe your architecture, those should answer questions for both humans and AI. And same with domain, right? I would even say prioritize making it make sense for humans, and then the AI can do the hard work of having to, interpret what's in there. But AgentsMD specifically, the AgentsMD has become a standard now, adopted by basically all these, coding agents. If you go to agents.md, it's a website with the standard, and you should optimize that one for AI.
Even Cloud is using agents now?
Yeah.
I thought it was using just the Cloud MD. Like,
No, I think they
Big
finally
annoying.
agreed.
okay,
Yeah.
good.
Yeah. Like Codex
yeah,
is using skills, for example, which for a while that was more of a Cloud thing. And yeah. Sorry, go for it.
Yeah. Well, another question in the chat is: an orchestration can be Cloud or OpenClaw. I don't know if that's
Yeah. For orchestration, yeah, it can be these skill MD files can be used by any of them. So at work, I use Cursor, and I also use the Codex CLI pretty extensively. And with Cursor, I'm using, Cloud models, or Cursor has its own, and they work. They each have their own like quirks around them, but they all support like sub-agents and a kind of an orchestrator loop now. They're kind of all converging on these like practices that seem to work for most people.
good. Great. Yeah, I have another question because I had to not long ago work on some of these files at my company where I work, and one question we all have, I think, at some point is if you have any advice on when and how you update these files, because they are meant to evolve over time, right? And I don't know if you have them like you update them along with other features. You have like a specific PR to update them. You have to get more people to decide those things. How do you work with those files specifically?
Yeah, we treat them as they're in source control. So yeah, you have to open a PR to update them and describe why you're updating them. I rarely touch them like myself by hand. I'm usually like, working on a feature or refactoring some code, and I notice that the agent is not doing something I wanted to do. And so I'll interrogate the agent about why are you skipping that rule, or what's going on here? And it will tell me like, oh, this requirement is vague, or that wasn't clearly stated in the skill. And so I'll tell it, okay, go ahead and update the skill so that next time you don't skip that. And it will do that. I prefer to keep those edits separate from the actual code change that you're shipping, just for reviewing purposes, because then you can send that as a separate PR and tell people, hey, I caught the agents skipping this step, so here's an update to the skill so that, it's clearly stated that they need to do this.
And so related to that, do you have any tip? Because I can imagine over time with having multiple files in different places, things can kind of clash. Like if you have something in your agents MD and then something in some like testing skill, and maybe they don't say the same thing. I don't know if you have any tips on that.
Yeah. I don't have a good answer for that. That's something we're observing too, especially with a large code base. It can become a burden. I think that's one of the trade-offs here, right? Like the more content you add in your code base, the problem now shifts to, okay, who orchestrates this? And it's a little bit harder than that. Like, for example, with code, you could make changes that conflict with each other, and hopefully you have a test somewhere that tells you, hey, the behavior changed here. With these markdown files that are written in English or human language, it's kind of hard to detect. What we've done is we control who's changing what. So at the top level, we have a team that is in charge of making sure that very specific things don't make it into the agents MD file that everyone's going to load. And then there's, more like the way our monolith is structured is like teams have their own subdirectories for the Rails side, and then for the front end side, teams have their own what we call workspaces. And so, we have experts that are in charge of maintaining that section of the code base in terms of instructions for agents. And so we had a case recently where somebody wasn't they were working with AI and the AI was not linting their files correctly and in JavaScript. So they came and wanted to add the instruction at the very top level because they were like, I want this to always happen. And turns out the rule was already somewhere else. They just hadn't found it. So it's a collaborative effort right now. And the only way we become aware of these changes right now is we have owners files that restrict who can change what. So at least you have to talk to each other.
Good. Yeah, I have one more question for the chat. It says, are there advantages of using a different agent for test and another agent for writing the code? Do you miss context when doing it in that way? Or is it because you are following TDD with this AI flow too?
Yeah, mostly TDD. So I highly recommend this set of skills called superpowers. I'm sure you've heard of it. It became very popular. Anthropic actually contributed to it. Yes. I see somebody asking if I tried the superpowers Ruby skill. I have. Superpowers is awesome. They already support sub agents by default, and when you are when you're doing so I have the TDD skill in there as well, and so if I give it a task that involves writing code, it will say on its own, activating the TDD skill, and I instructed it to use sub agents, so it's going to use a sub agent to write the tests, run them, make sure they are read, and then they're failing, and then another sub agent takes over the implementation. So it is it's been super helpful. And initially it seems like a good idea to have all the context in one place, but honestly all that leads to is the agent to know too much, and sometimes it will get a failing test and it will change the test instead of fixing the code to be more permissive, and it can be tricky to catch those. And so separating the roles kind of keeps each agent on their line without cheating.
Good, great. There's another question. It says, do you use memory to save context between sessions?
I have. It depends on the task. Sometimes it's actually better. It at some point, if you want a fresh perspective, if that makes sense from an agent, because you might be working with an agent for a while, and you have you have memories enabled, and that previous context starts to influence the new exploration you're doing with the agent. Sometimes it's good, and sometimes actually gets in the way, and so it really depends on the type of task I'm doing. Yeah.
Yeah, I have one last question from me. I don't know if anybody has one more in the chat later. But when you gave the example of the requirements MD file, at least to me that looked like one single task you had to do. And I don't just to be sure if I understand that properly. The idea is when you need to do a different task, you write a new requirements MD file, or that is, for example, that example of doing something dark theme, it's something you do often in different parts of the application. That's why you have a skill for that.
Oh, I see. No, so yeah, thank you. Maybe I should look into making that more clear in the presentation. That's a great question. No, the idea of the requirement skill is that it's a skill that helps you refine requirements, any kind of requirements. And then the outcome, in this case, I had it in a markdown file, but the outcome of the requirement skill could be an update to your Jira ticket or whatever ticketing system you use to track work. And so the way I use my requirement skill is when I give my coding agent a task, I'll usually give it a ticket number and tell it, hey, we're going to work on this. It goes and pulls the information in the ticket, and then it uses the requirement skill to evaluate, is this ready for, an agent to work on? And if it's not, it will ask me a bunch of questions like, what is the acceptance criteria here? Should the dark mode, for example, cover the entire site, or are you working on a particular section? Should we refactor all the CSS, or do you just want to add more to it? And so it kind of works with you to think through what you actually want to accomplish and then captures that back into the ticket. Sometimes you might have to go back and talk to your product person or your customer to clarify what it is that you want to do. And so it's the same skill, but the output depends on whatever the input was, if that makes sense.
Yeah, makes sense.
Cool.
Yeah, okay. I think there are no more questions from the chat. So I think we are good. Thank you again, Fito. Gracias.
Bring Alan again.
Good night.
Alan, I'm gonna bring you back again, so just you're aware. Tuki. Cool. So, thank you guys for coming today.
Thank you, Cisco Meraki.
Thank you, Cisco Meraki.
They are both from Cisco, just
Thank you for lending them to us. I hope you had a really good time. I hope you guys in the chat and wherever you are in the world watching us, and if you are seeing us after this, I hope you're having a good time as well. Greetings from Rosario. Saludos a todos. So, well, I hope we can have you again someday in the future when you have another talk to share. We'll be able to have you back again. I don't know. I'm just so excited when we have international speakers. I find it amazing. Anything you want to add? People can contact you in your social media or LinkedIn and stuff.
Mm-hmm.
Cool. Yes.
Yeah, if you have any question for them or feedback, share that with them because they are happy to receive feedback.
Absolutely. These were practice runs for RubyConf next month.
Yeah, we have a list of talks, so we'll be happy to come back anytime and give another one.
Cool. Well, so thank you all. Thank you to our sponsors as well. Thank you to Rootstrap, thank you Ombulabs, and thank you Synaptia. And thank you all guys, you're there in the other side of the screen watching these talks every month. It makes us really happy. Remember that if you want to give a talk and you want to be a speaker, you can be a speaker. There's a form down this video, and you can check it out and put your name, or you can nominate some colleague of yours if you think they really have something to share and they're really intelligent at what they do, they are remarkable of what they do, or maybe you think they're onto something. You can nominate your colleague or your friend, and we will send them an email and say, hey, I think someone thinks you're really intelligent and you should have a talk. So yeah, ¿algo más, Ari?
If you want to be a sponsor, si quieren ser sponsor, también se pueden contactar en nuestro sitio ruby.com.ar. In English, you can be sponsors.
And remember, we have one talk that is remote and the other one it's on-site. But at the same time we do the on-site, we also do remote. So if you are here in Argentina, come join us in Buenos Aires. Next meetup will be at the end of July because we are waiting
July
for the
23rd.
Yeah.
After the World Cup.
Yeah, after the World Cup. So no intermission for that. So if you are in Argentina, you can come and join us in a on-site meetup. And if not, you can always join remote. Thank you, Alan. Thank you, Fito, again. And yeah, have a good night. Bye.
See you.
Ciao.
Ciao.